Welcome back to another AddMaths tutorial video, where today I'll be covering Form 4 Chapter 4, Indices, Surds and Logarithms. Alright, so today we'll be looking into Chapter 4, which is Indices, Surds and Logarithms, where we'll be looking into the individual laws for each, which is the laws of indices, followed by surds and also logarithms. Alright, so we have about 7 laws of indices, so let's go through them one by one. The first one is a to the power of m times a to the power of n is equal to a to the power of m plus n. So let's give an example here. Let's say I have 2 to the power of 2 times 2 to the power of 3 is the same thing as 2 to the power of 2 plus 3, which in this case is 2 to the power of 5. Alright, very simple first one. Now the second one, we have a to the power of m divided by a to the power of n equals to a to the power of m minus n. So it's just the opposite of the first law. Instead of adding, you are subtracting. So let's just do it again. 2 to the power of 2 divided by 2 to the power of 3 equals to 2 to the power of 2 minus 3. So I'll get 2 to the power of negative 1, but you should write it as 1 over 2. Now let's look into the third law, which is bracket a to the power of m n. Alright, so this is like the multiplication law basically. So let's say I have 2 to the power of 2 in the bracket, 3 outside. So this is the same thing as 2 to the power of 2 times 3, which is 2 to the power of 6. So just think of like BOD mass, you know, when there's a number outside, you times it. Alright, let's look into the fourth law, which is when there are 2 values, so a, b to the power of m. So usually we use this one when there is a unknown. So let's say it's 2x to the power of 2. Basically, it's going to be 2 to the power of 2 times x to the power of 2. Basically, you're going to multiply both. Alright, sorry, I forgot to rephrase this. It's a to the power of m and b to the power of m. So you have to basically multiply with the indices of 2 to both. So it'll become 2 to the power of 2 and x to the power of 2. And then you just have to give the exact value, which is 4x squared. Now let's move on to the fifth law, which is a over b to the power of m. So this is literally the same thing, but you're going to do it when b is basically the denominator. So this is going to be the same thing, a power of m over b to the power of m. Alright, so simple example, let's say 2 over 3 to the power of 3. I will get 2 to the power of 3 over 3 to the power of 3, which then equals to 8 over 27. Now let's look into the sixth law. The sixth law is when a is to the power of 0. So basically anything to the power of 0 will equal to 1. Alright, but if it is a to the power of 1, it will become itself a. But a to the power of 2, that's when it becomes a times a, alright? And a to the power of 3 is just multiplied by itself 3 times over and over. That's how it works. One thing to remember is if it's a to the power of a negative number, let's say a to the power of negative 1, it'll become 1 over a. It's basically like dividing 1 by a. And then a to the power of negative 2 is just repeated after that, so it becomes 1 over a squared. Now the final law, seventh law, is when a is to the power of a fraction, a to the power of m over n, will become, basically, if the denominator will be a root, the numerator will be your normal indices. So in this case, a to the power of m over n would be n surd a, but then you would have m outside. You can actually write this in multiple ways. You could write it as n root a to the power of m. You could even still write it as a to the power of m 1 over n outside. There's multiple ways, but usually I would use this one over here. It's way easier and you can actually see it, because if you were to use this one, since the m is inside, it's quite hidden, I can't really see it. But this one is very obvious with the bracket and the surd outside. Alright, so let's say I'm given 8 to the power of 2 over 3. So I would write this as 3 surd 8 to the power of 2. So that would be the same thing as you know, the cube root of 8 is 2, so it's 2 to the power of 2, I will get 4. Alright, so now let's look into the law of surds. So the first one would be n surd a can be written as a to the power of 1 over n. We've covered that just now. And if the denominator is always going to be a surd, or a root, I would like to call it. And so let's say if I were to have 3 surd 2, I would get 2 to the power of 1 over 3, alright? Okay, so let's look into the second law now. So if n root a, basically let's say n is a coefficient, right? So I could rewrite this as basically root a plus root a and so on, just adding by itself. Okay, let's give an example. Let's say you're given 3 root 2. I could write this again as root 2 plus root 2 plus root 2, as if root 2 itself was a unknown, alright? And I only add it 3 times because it's 3 root 2, so it's the same thing as 3 times root 2. Alright, so let's go into the third law, which is root a times root b equals to root ab, alright? So let's give an example. If it was root 2 times root 3, I would get root 6. Basically this works because you have the indices being the same, which is power of 1 over 2. Since they have the same root, therefore they can times each other. Now let's look into another one. Alright, the fourth law. You have n root ab. Basically this can be rewritten again as n root a and n root b. Now this isn't the coefficient, alright? This is if it was, let's say, cube root or square root. Let's write that again. So if you've been given cube root 2x, you could rewrite this as cube root 2 and also cube root x, alright? Alright, now let's move on to the fifth law, which is root a divided by root b. So this can be rewritten as big root a over b. Alright, since you would actually be getting like root a over root b, and then you could put them into the same root basically. So let's give an example. I've been given root 2 divided by root 3. So I could write this as root 2 over root 3, or I could just straight off write this as root 2 root, alright? Root 2 over 3, alright? Now let's look into the last law, law number 6. Alright, so law number 6 would be basically the same one with the multiplication, but this time it's n root a over b. So just like what we did just now, you can basically expand this to become n root a and root b. So let's give an example. I've been given let's say 4 root 2 over 5. So I could write this as 4 root 2 over 4 root 5, alright? So that should be everything for law. Alright, now let's go into the laws of logarithms. So this must be a new topic for, well, Form 4s usually, because you already learned indices and surds in lower form. But basically the way logarithms work are like this. So let's say you've been given, let's give a normal indices, 2 to the power of 2 equals to 4. So how are you to change this into log form? So basically the way this works is you take this, the first number over there, as the base number. So that would mean that you become log 2. And you would write 4 over here as the number to be logged. So that would be log 2 4 would equal to the indices over here. So log 2 4 equals to 2. So it's basically like the opposite of indices, but it's basically to find 2 to the power of, it's the same thing as the base over here to the power of what it is equal to will get your number to be logged over here. So sometimes questions will actually tell you to write in certain indices in log form, so you will have to understand how this works. So let's look into the first law. Alright, let's say you've been given log base a and the to be logged is a, Basically, since the base and the number is the same, you get 1 because a to the power of 1 would get a. Alright? So let's look into number 2. We have log base a 1. This would equal to 0 because we know from indices anything to the power of 0 equals to 1. So a to the power of 0 equals to 1. Now let's look at the third law. We have log a xy equals to log ax plus log a y. So this is basically like the multiplication law of log. So basically, let's say you've been given log 2 3 plus log 2 5. This could be written again as log 2 15. Alright, so it's basically saying that the number 3 over here has to be multiplied with the number 5 over here. Just keep in mind that this law only applies when the base are the same. Alright, so if it was, say, log 2 3 plus log 3 5, you couldn't use this rule. Alright, let's move on to the fourth rule. Alright, the fourth law is when log base a x over y is the same thing as log base a x minus log base a y. So this is the subtraction law, basically. It's like the division law. So it's the opposite from law 3. So let's give an example. Say you've been given log 2 5 minus log 2 3. So this would be the same thing as log 2 5 over 3, you know? So basically it's the opposite of number 3. You just have to divide in this case. And also keep in mind the base number has to be the same for this law to work. Alright, let's look into number 5 now. We have log base a x to the power of n. Basically this can be rewritten as n log a base a x. So let's say I give an example, right? Log 2 3 to the power of 3. This could be rewritten as 3 log base 2 3. Alright, so this is usually very helpful when you're trying to prove something, especially when you're working with law of coefficients. Let's look into the sixth law, which is, alright, this is quite of an important one, but it's also quite difficult to remember. Log base ab. Basically this is when you want to change the basis of your logs. So you have to rewrite it as log cb over log ca. Basically the base will stay at the bottom, whereas the number that is to be logged, which is on the top already, stays at the top. Alright, that's how you get log cb and log ca. C is basically the new number, the new base that you wanted. Like say you already have log 2 3, and I actually wanted to change this to a log of base 4. So I could actually get log 4 3 over log 4 2. And basically I could simplify this to become log 4 3 over, since we already know log 4 2 is square root, so it would be 1 over 2. And you could bring it up. So basically that's another whole part of logarithms, especially in proving. Very important one. Alright, now let's look into the seventh law. The seventh law is basically what I showed you at the start, which was to change the log into the indices, which is when log base ax equals to y. Alright, so if you wanted to change this into indices form, it will become a to the power of y equals to x. Right, so let's give an example. Log base 2 8 equals to 3, right? So that would mean that 2 to the power of 3 equals to 8. Yep, exactly how it works. Alright, now number 8. Law number 8 is if log ax equals to log ay. Basically, therefore this means that x equals to y, because if the base were the same, that means the top numbers have to be the same also, if for them to be equal. Alright, now let's look into the ninth law. The ninth law, right? So when the number is powered to a log with the same number, alright, basically the number to be logged at the power will equal to itself. Alright, so let's take an example and how do we prove this law, alright? Because this is something a lot of people don't understand how it works. So let's say you've been given 2 to the power of log 2, 3, and we already know that it's going to equal to 3. Basically, this is usually for proving. So, let's say that it's log 2x, alright? So we want to prove what x is. So in this case, we would know that if you wanted to pull an indices down, you would have to actually log the whole equation. So let's first do log 2 to the power of log 2x equals to log 2, 3. So since we already learned the law initially, it will become log 2x times log 2 equals to log 3, right? So let's imagine this is being multiplied to each other. So we already know that if the base and the number to be logged is the same, it will equal to 1, right? So you'll be left with log 2x equals to log 3. And basically, if you make the logs disappear, therefore you can say that x equals to 3. There you go. So that's a very easy way to prove this works. So usually examiners know about this law. Basically, they know that when a is to the power of the same thing, you can straight away say that cut these off and say that it is b, which will equal to b. Basically, just like that. It's a very important one to remember. A lot of K-Bar questions have this law specifically, but it isn't widely used. But it's quite of a tricky one, especially if you remember how to do it. Alright, so before I end the video, let's just run over some quick tips for this chapter. Alright, so number 1, I would recommend anyone who is trying to get better in this topic to basically remember the laws, to memorize them. Basically, when you actually memorize these things, they're in your head already. You actually can do these things faster, especially when you practice. Alright, number 2, I recommend just trying to start from somewhere. Just do it. Basically, even I get confused when I do indices, surds, and logs sometimes. So what I do is actually I start with a pencil. I write my pencil, and then when I actually get confident with my answer, that's when I shift to a pen. So I would erase my working at the end. So it would be faster. You would actually be thinking as you do it. But lastly, and the most important one, is to rationalize. Basically, if you were to leave your answer as, let's say, 1 over surd 3, this would be incorrect. You actually have to rationalize this by multiplying the denominator and the numerator by root 3, so that you'll equal to root 3 over 3. So, but sometimes you actually have an expression as your denominator. Like, let's say, for example, 1 over root 3 plus root 2. So how would you rationalize this? Basically, you times the bottom and the top by root 3 minus root 2, root 3 minus root 2. Basically, multiply both numerator and denominator by the opposite sign. As in, if this is positive, you times with negative. So what I would be left with up here is root 3 minus root 2 over 3 minus 2. So I'll be left with root 3 minus root 2, alright? The reason why we would multiply by the opposite sign is because you would actually immediately get rid of the root 6 over here, when the root 3 times the root 2, when the root 3 times the root 2, you immediately get rid of them. So let's make another example, possibly 1 over root 3 minus root 2. Like I said, multiply by the opposite sign, so it's root 3 plus root 2, root 3 plus root 2. So I'll be left with root 3 plus root 2 over 3 minus 2. Same thing, but different signs, of course. But basically, when you do rationalizing, always use the opposite sign so that basically the AB will cancel each other out. In this case, the root 6 would cancel each other out, so you'll be left with only root 3 squared and root 2 squared over here, alright? Alright, thanks for watching the video. Please look forward to the next ones. Ciao, Lu!